Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig. We have been building on AWS since 2009. Follow along as we develop products like bucketAV, marbot, HyperEnv, and learn from our practice. This is episode number 89, and we are recording this on April the 18th in 2024. In case you're watching this live on YouTube or LinkedIn, feel free to send us your questions in the chat, and we will either answer them directly or at the end of the show. So, Andreas, what's the first kind of topic we are going to cover? It's a little surprise, right?
Yeah, Michael. So we have an announcement to make, and I think you should show it to the camera.
Yeah.
So the third edition of our book, AWS in Action, was actually translated into Japanese and is now available.
This is how it looks like.
Yeah.
I don't know if you can see it.
Yeah, you can point it a little higher. And so the thing is, we are really proud of that, so that our book is translated into other languages. Unfortunately, we cannot read Japanese, so we don't really understand what's in there. But it's really cool, and we have one copy that we are happy to send out. So if you are able to read and understand Japanese and want to learn about AWS, write in hello@cloudonaut.io. And we are happy to send you the signed copy.
And I was very happy to receive this package. Right, it had actually had a long journey. So it started in Japan, then it went through China, and then it went all the way to Frankfurt in Germany. So it traveled quite a bit. And also we really like, or we really appreciate that the publisher is sending us books. Not every translation is actually sent to us, but the people from the Japan or from the publisher in Japan really always send us the book. So they also translated the first edition, and we also have that. I also have that in my bookshelf behind me. So it's really cool. I mean, it is very cool. I cannot read anything, but it's really. I'm very proud of it. It's really cool to see the book translated into other languages. And there are a couple of other languages in the works, Andreas, as far as I remember. I don't remember the languages, but yeah, there will be other translations as well. Okay, so let's dive into the first real AWS topic, right?
Let's do that. Okay.
So I was working on a feature in bucketAV, but this is not bucketAV specific, so you probably, or you might need that as well in other parts of your applications. And the kind of goal is to move or copy a file in S3, either cross buckets, or also if you want to kind of rename it to another key name. And there's an API for that. It's called the Copy Object API. And this has one limitation. It only works for files smaller or equal to 5 gigabytes in size. So yeah, what to do if you have a larger file to copy, because S3 actually supports files up to 5 terabytes. And the answer to that question is you have to use multi-part upload. This sounds, I would say, less complex than it actually is. To make it work, you need to interact with a couple of APIs. So first, you call the create multipart API, and this more or less only returns you an ID, the so-called upload ID. One thing to keep in mind is that this API does not copy the metadata like tags and stuff out of the box. So if you use the copy object API, the metadata will be copied as well, not if you use the create multipart upload API. Okay. The second step that you need to do is you now actually need to copy each and every part. And there's a specific API for that as well. It's called the upload part copy API. And basically what you put into that API is you reference the source, so the bucket and the key, and the optional the version, and you specify the byte range to copy. So for example, you could start from byte 0 up to whatever byte that you like, the size of your part, and you also define a part number starting at 1. You can call this API, and that's kind of the cool thing, in parallel to speed up the copying process. So basically you can copy, for example, 100 parts at a time, or maybe even more parts at a time. Two limitations to take into consideration. First, max part is 10,000. So if you have a file that's, I don't know, 5 terabytes in size, you cannot divide it further than in 10,000 parts. And one other limitation that you have to keep in mind is that the part size must be between 20 megabytes and 5 gigabytes. And just for the very detail-oriented listeners, if I say megabyte here, then it is always the not the factor by 1000, but a factor of 1024 megabytes. So MIB. Maybe bytes, I think, is the correct term here. So if you look at S3 documentation, it's always very confusing. Sometimes they tell you megabyte or gigabyte, and sometimes they say maybe byte or gigabyte. So it's always the one with 1024 as the factor. All right, once you uploaded all your parts in parallel to speed things up, you have to call another API, the so-called complete multipart upload API. And this more or less references all your parts and the E tag of each part. And again, the upload ID. And then as soon as you call this API, the file pops up in S3 as one thing. If things go wrong, there's also an API called abort multipart upload. And if for whatever reason something goes wrong, you have to call this API to kind of delete all the already uploaded parts that are in S3. Otherwise, they will stay there and they will charge you for the storage. So that's something to keep in mind.
Michael, I have a question. So what you're describing is the process to upload large files to S3, but that is not specific to copying files. That's the same process that you do when you upload it from somewhere else, right?
The process is more or less the same. The only difference is that I call the upload part copy API instead of the upload part API.
Okay. So there's a specific API for doing the copying. Okay.
Yeah.
Okay.
But the start and the end, the create multipart upload and the complete multipart upload, that's exactly the same, no matter if you copy or kind of upload something from scratch.
Okay, thank you.
That's right. Okay, so I thought, okay, that's a perfect match for an AWS service that I like. It's called step functions. Because in step functions, you can actually define all the steps. You can also parallelize very easily. And if something goes wrong, you can also have an error handler and then call some code to clean everything up, which is the abort multipart upload API. So sounds great. I started to work on that. And there are a couple of details to take into account. So in step functions, parallelization can be implemented with a so-called map state. And this can be in either distributed mode or inline mode. So what does this mean? Distributed mode, there are a couple of nuances to this, but for our use case, the most important difference is that in distributed mode, you can achieve concurrency over 50, while in inline mode, the concurrency is maxed at 50. So if you want to copy more than 50 parts at a time, you have to go with the distributed mode. That's the path that I went. Within distributed mode, you again can make a choice. You can use express or standard executions. The main difference in express versus standard, besides pricing differences, is that an express execution can run for a maximum of 5 minutes, while the standard execution can, I think, run for 1 year or something. So, that's one important thing to keep in mind. In theory, I think you could use the AWS service integration, AWS SDK service integrations, to call S3 APIs directly from step functions without any Lambda function to achieve what I just said. In my case, I was not looking into that because I need to dynamically assume an AWS role before I call the S3 API, and that's not supported by the AWS SDK service integration in step functions. So I basically went with Lambda functions. So I first do the S2S assume role call, and then with those credentials, I call the S3 API. That was kind of, it's not bad practice or anything, but it would be nicer if I could do everything in step function without a Lambda function, but that's unfortunately not possible. The next thing is, what I learned is that the upload part copy API with, for example, 5 gigabyte part can actually take 5 to 10 minutes to respond. So I think basically what happens is you call the API and then AWS starts copying the data, and once they are done, they return the API. So it's a synchronous API. So there's basically a trade-off between how many parts you have and how large those parts are, and then how long it takes to copy a single part. I ended up with 1 gigabyte parts. That's probably not the kind of optimum. The question is what you optimize for, but it is good enough for my use case. One thing that I also learned is that there's a big difference between regions, how long it actually takes to copy data. So because we run acceptance tests in all regions, I really noticed that in, for example, smaller regions, it can take much longer for a 5 terabyte file to finish compared to, for example, US East 1. So that's something that you probably have to keep in mind if you run in multiple regions, that it can take different amount of time to copy a file actually. Yeah. Another thing that I learned, Andreas, is I started with the express execution mode for the upload part copy step. Because, yeah, I thought that probably is a better fit because I have a lot of executions if I distribute it. And there are actually some quotas on how many executions you can have running at once in step functions in a region. So I thought, okay, if I go the express route, I don't run into those quotas because for express there are no such quotas. But the problem is that the copy can really take much longer than I expected. And because of the hard limitation of 5 minutes in express executions, I switched back to the standard execution model. And I actually also was unsure about the pricing considerations because I was trying to figure out what it will cost me when I use Express versus what it will cost me using the standard execution mode. But I was not really able to answer that question, to be honest. So the way they are priced is very different. So for standard executions, you pay per state transition. In my case, there's not a lot of state transitions. It's basically one state I enter and then I go to the success state for each part copy upload. While for express executions, you pay per time they are running. So when they basically wait for my Lambda function, which is running for 5 minutes, then I pay for 5 minutes as far as I understand. So it is actually then more expensive in the end. So yeah, I'm not entirely 100% sure about that, to be honest, because the data doesn't really seem to be available to kind of answer the question easily, but that's what I think what happened.
Okay.
But because of the 5 limitation, I also went with the standard mode.
Okay, Michael, so I have a question about the parts. So you say that you can define the size of the parts that you do for copying.
Mm-hmm.
And when we copy, that means we're copying a file from one S3 bucket or from one S3 object to another S3 object. And what I've learned is that when you initially upload the file to S3 and you do a multipart upload there, that's also the part size that AWS keeps basically when storing the object. So when you do, you have worked on this get object accelerator. So I understood that when you download the object again that was uploaded in multiple parts, it's the most efficient to download it with the same part size than you did with the original upload. So how does that interfere with the copy upload part?
Andreas, this is actually funny because I had the exact same question. So when I looked at the API, like the part copy API, I thought that, okay, if I don't specify the byte range and just the part number, they will just copy the part, like the exact same number over. Turns out that's not the case. You always have to specify the range. So I think for the copy part, it's not that relevant what you just mentioned, what is relevant for downloading, because you just do it once, right? I mean, downloading will happen many times for the same file. So there is no way, as far as I understand, to just copy part 5, for example. You always have to specify the byte range. I mean, that's kind of the difference. If all your parts use the same byte range, which is not necessarily true, because you could have different ranges for every part that you upload for the same file, you could probably look up the first part size and then use that for all the other parts. But yeah, I think that's not really a big problem. Also, it was never mentioned in any of the documentations about multipart copying from AWS that it's a problem or anything to consider.
I was just thinking because I thought the maximum throughput you get depends on if you choose the same part size for downloading that you used for uploading. So when you copy a very large file, that should have the same impact actually. Yeah, interesting. Okay, maybe the API is just not that advanced.
Last learning, Andreas, but this was also an interesting one that I didn't add to my list. But it doesn't seem to be possible to copy a single part by just referencing the number. What also is important, as I said, if things go wrong, you have to call the abort API. In step functions, there are some situations where this is not possible. For example, I have a timeout defined for my whole state machine, I think it's 1 hour or something. And if that timeout is hit, the execution of the state machine stops and it cannot execute the fail state then, the abort state, because the whole thing is already timed out. So in this case, there might be parts uploaded, but there's not yet the complete API call. So there will be parts left in S3 that never be deleted. So for this case, it is possible to create a lifecycle rule on the bucket. And the lifecycle rule says, okay, delete expired object delete markers or incomplete multipart uploads. The second kind of part, incomplete multipart uploads, is what we need. And you can specify a number of days. And in my case, I just went with 1 day. So after 1 day, all the incomplete multipart uploads will be deleted. And then you will not end up with a lot of like kind of data garbage in your S3 bucket that you have to pay for. So that's something to consider as well.
Okay.
That's kind of it, Andreas. I think I'm going to write a blog post about that, hopefully in the near future.
You should, Michael. You definitely should.
Sharing the step function and stuff.
Because I will forget about that, and when I run into the same issue in the future, I have to have some reference for that. That's very interesting.
One last information I missed, Andreas. It takes around 10 to 15 minutes using my approach with, I think I have 100 as the concurrency factor. It takes around 10 to 15 minutes to copy 5 terabytes, a 5 terabyte file in S3 in the Ireland region, which is good enough for our use case. But you could probably speed that up by increasing the concurrency. I don't know when you will hit the S3 API rate limits, but I think you could kind of optimize that further if that's a concern, if you need to like speed up the copy part. There are other features in S3 that help you with copying files, but none of those features help you to copy a file as quickly as the one that I just shared with you. So there are like batch operations that you can use to do the same, but before they actually start running, this will already be finished, basically, the one that I showed you. So that's much quicker.
Very cool, Michael. Thanks for sharing.
Yep.
Okay. So the next topic is about basically keeping dependencies up to date. So Michael, whenever we use infrastructure as code, we typically try to build modules. So for example, we do Terraform modules. We even found a way to do CloudFormation modules. That's something you worked on a few years ago. And the idea is when you have modules, you can easily stick them together to build different use cases. And this is, for example, a very interesting concept, I think, for accelerating large organizations so that you have a team working on modules that allows teams in the organization to deploy their applications on AWS as quickly as possible by following the governance rules that apply in this specific organization, so that you have standardized ways of deploying stuff on AWS, but still each team can customize their infrastructure to their needs for different kinds of applications. But if you do use this approach of having modules and then teams are using those infrastructure modules to build their stuff, you then run into the problem that how do you ensure that all those modules that people are using stay up to date, so that all the dependencies stay up to date. And this was the challenge I was facing. And I was looking for a way to have an automated way to keep dependencies up to date. And so I was looking around for a tool that can help with that. And Michael, I don't know if you have ever run into a tool that GitHub provides. So on GitHub, there is the so-called DependerBot. And DependerBot is, I think the goal is to raise the security bar for open source projects. So I know that DependerBot just notifies you about there are NPM packages that are outdated or even have security vulnerabilities, and DependerBot is doing that. So my first idea was maybe we can use DependerBot. And yes, DependerBot does dependency updates automatically, but only for pre-configured package managers and tools and stuff. And so I need to look for another tool. And I found a tool that is quite interesting, I think, and I want to share it today. It's called Renovate. And Renovate is an automated dependency updater. And it's both. It's an open source project, and it is a software as a service offering. So that's maybe the first interesting thing to know. And to me, as far as I understand it, the software as a service offering targets enterprise customers because it starts at 25K per year. So it seems like they are targeting large organizations to sell to. And probably the open source project is for smaller customers that just want to use the tool. So that's what I at least understand the strategy from looking at the documentation and their website. Okay, and what does Renovate, the open source version, support? So first of all, it supports all the source code management tools out there. So you can use it with GitHub, with GitLab. I think it's even, I didn't remember it correctly, but I think it's even code commit that is supported here. So because the tool needs to look at your source code, so it needs to integrate with those tools. Okay, and then it comes with a large list of code and dependency that it understands. So for me, interesting is it supports Terraform, TerraGrunt, Docker, and even maybe more, so Helm, other container-related tools. And then, of course, many package managers are from many different programming languages. So NPM, obviously, but also in the Java world and basically everywhere where you have dependencies and packages. So that all comes out of the box, which is very cool. And even more interesting, Renovate also supports writing custom dependency definitions. And it's quite relatively simply to do. You can do it with regular expressions. So basically you define a regular expression that then goes through all the code and finds the dependencies that you're looking for. And this worked very well for my use case. The use case is private Terraform modules, so internal Terraform modules that are hosted on S3. So, and I could solve that problem with a regular expression quite easily. So I know regular expressions are always kind of tricky, but after fiddling around a little bit, I found the regular expression to do that. So this was very interesting. And then basically you do that. That's basically the configuration for Renovate that you do. You write that into a configuration file. And now you could either use the software as a service version of Renovate. So if you're a large organization, that might be worth looking into. Or you can self-host Renovate. And there are different options to do it. And I wanted to talk you through how I deployed it. And I found this was a very simple way to do so. So the code that I needed to scan was all hosted on GitHub. And so I thought about maybe I can run Renovate just as part of a GitHub workflow, as a GitHub action. So this was my idea. And that how I achieved that is, first I created a GitHub app because you need some credentials to access the repositories in the organization. So I did that by creating a GitHub app. The problem with creating a GitHub app, so that's quite simple. You create a GitHub app, then you install it to the different organizations that you want to use it with. And then the only thing that was a little more tricky is the GitHub app has static credentials to authenticate as the app itself, but you then need to fetch temporary, they call it installation tokens. So that's basically the token to access then the data in the organization and the repository. So I wrote a few lines of Node.js code to basically fetch those temporary tokens. And so that was the first part. And then luckily, Renovate, they provide a container image. So I then just start the container image provided by Renovate and hand over the configuration and the token. So all that runs as part of a GitHub workflow. So that means I can use, in my case, I'm just using a schedule so that this runs once a day. And so once a day, the GitHub workflow starts and it will fetch the token and then start the container that runs Renovate with the config that is stored in the GitHub repository that basically manages this workflow. So I found that relatively simple to implement. first I thought, oh, maybe I need to do something with Fargate and stuff, but then I found out, oh no, I can just use what I already have, so I don't need to deploy anything new. And then how Renovate works. So this is not specific to my deployment, so that's how Renovate works in general. So first it fetches all the accessible repositories. So the token that you hand over, and it tries to fetch a list of the repositories that this token has access to. Then it scans through the code and sees if it finds any part in the code where there's an update, where there's a dependency where an update is available. And if there is one dependency where there's an update available, Renovate creates an initial pull request. And the pull request basically says, hi, I am Renovate. I found the following, and if you want to activate me, just merge this pull request. And all that the pull request contains is basically a configuration file that is then placed into the repository so that Renovate knows that it's enabled. And if you want to do some custom configurations for a specific repository, you can add that there too. And then if that pull request is merged and Renovate is activated for that repository, the next time you run Renovate, it will then create the pull request that is actually then updating the dependency. So we get a pull request, which basically just increases the version number of the dependency in the, in the Terraform file, in the package JSON of NPM, where have you. And this is really cool. And I think it's a very convenient tool. So it's like a bot that is built on pull requests. So I found that interaction with the bot quite interesting. They even have, in the pull request, you can tick checkboxes in the Markdown, so in the HTML that is rendered after Markdown, and to enable certain features and stuff. So they really integrated everything into the GitHub user interface here, which I found quite cool. And yeah, I think this is a really clever tool to make sure that infrastructure or container or even developer dependencies from programming languages are kept up to date. And as we all know, this is really, really important to ensure that you can ship security patches quickly or even benefit from the latest features and stuff, and improvements. So yeah, I can highly recommend looking into Renovate.
All right. One question, Andreas. When you say you can self-host it, and does it need a database or does it keep all the data inside GitHub basically?
No, yeah, everything is in GitHub. So it's actually everything is in the configuration file, and it doesn't need any database. Yeah. So it's relatively easy to run. You can even run it from your local machine if you want to. But I think in a large organization, it makes sense to deploy it.
Yeah.
Yeah. And the software as a service is, I think, definitely an interesting option for, I think they target customers with more than 100 developers. So if you fall into that category, check that out. I think that's probably solving many of the issues that you otherwise have to solve yourself. Yeah.
All right.
Okay. So last but not least, Michael, let's go through some of the AWS news. So since we recorded last time, there was a lot going on. So I picked up 4 announcements that I found especially interesting to discuss with you. So the first one, Michael, is Amazon DynamDB now supports resource-based policies.
Yeah, I saw that too.
So what are your...
I was kind of divided. I mean, it's for cross-account, it might be a good idea, but on the other hand, it is not a good idea to share your database across accounts. Because you basically integrate over the database in that case, and that's probably not a good idea. But yeah, what's your take on it?
Yeah, so I think AWS is repeating a huge failure that they have, or mistake that they made with S3. So I don't know how many data leaks we have seen resulting out of this possibility to have your S3 bucket policy and share data to the world. So why do we need that for DynamoDB? I don't know. So it doesn't make much sense to me. Also, I never had, so we are using DynamDB quite a lot, Michael, but I never had the urge basically to share a DynamoDB table with multiple accounts. I think it's probably just in 99 of all cases, it's just a bad pattern. Because as you said, why should you integrate over the database? So I think the security risk that comes with that is quite high. So misconfigurations will definitely happen. People will share their databases with the world. And I don't know if that's really what we needed, but yeah, okay. I don't know. So
Yeah.
Okay. So one aspect to it. So one option I had. So I thought one idea to use it is to share the DynamDB event stream with other accounts so that they can basically subscribe to that. So I don't know. That's maybe an interesting aspect to it. So then you're not sharing the database, but just the right events. But if you do that, why not just use a real event stream with the original event instead of the data event? So even that, I don't understand why this is important, but yeah. Okay, moving on to the next one, Michael. AWS CodeBuild now supports custom images for AWS Lambda Compute.
Yeah, I'm not sure why I need it, but maybe you have an idea.
Yeah, so I picked that because I find the idea to run CI/CD jobs on Lambda quite interesting. So of course, we have a lot of limitations. Obvious one is 15 minutes. It's a big limitation. But if you have really short CI/CD jobs that you need to run, I think having that capacity the scalability of Lambda is interesting. You can quickly spin up a compute job on Lambda instead of on containers or even EC2. So that is why I found it interesting. And with that possibility to bring your custom image to the Lambda function that CodeBuild starts, you can, of course, include the tools that you need. Obviously, you need, I don't know, YAML lint or whatever you want to. I think it's perfect for linters, probably. They typically run only a few seconds or maybe a few minutes. So you could bring them and then just run them with Lambda. And I think compared to starting an EC2 or something, that should be relatively fast and scale very well. So that's why I found it interesting.
Yeah.
I looked into the pricing. That's quite cool. So if you run CodeBuild on Lambda, you're paying 10 times more than if you run it directly on Lambda, which is quite a lot for a few lines of code that they have written, probably. Okay, but yeah. So here we go. So what I thought in general about this is maybe this is something for our product HyperEnv for GitHub Actions. And I thought maybe we can somehow integrate a Lambda alternative there as well for smaller jobs. Definitely something I should look into a bit and see if we can have that running. Because CodeBuild, you can basically connect CodeBuild with GitHub, but you can't run GitHub Actions as they do in GitHub on CodeBuild. So that's still not possible. Yeah, so that's the other thing. Okay. So Michael, next one. AWS CloudFormation change sets now offer enhanced change visibility for deployments.
Sounds great.
Yeah.
To be honest, because change sets is really lagging a lot of visibility.
Yes, it does. And also, I'm so happy that the team around there seems to be a new team working on CloudFormation. Yes. Right? We see new features every time we record. So that is
back on the stage.
Yay.
CloudFormation, yeah.
So it's not that. Okay, so yeah, and I looked into it. So as you know, when AWS announces something that sounds interesting, I'm always trying to check if it's really that cool. So what did they build here? So they basically improved what you see when you basically a change set is when you update a CloudFormation stack, you can create a change set, which means CloudFormation will first show you what it will change and then apply the changes in a second step. So just for those who are not so familiar with CloudFormation. And what they showed before the change, what you saw just a list with resources that CloudFormation will add, modify, or delete. So this was more or less what you were seeing. And if there was a modification, you couldn't really see what was changed in there. And if you know Terraform, there you see exactly which properties of a resource are getting changed. And that's what they are implementing now with this feature. So you now, for every resource that gets modified, you can click into the details of that resource, and there you will see 2 JSON files with the properties on the left and on the right, so the old and the new state. And at the top of that, you see a table that summarizes the changes, and then you see old value, new value, and so on. So the user interface is I think, a very, very first beta version of what you can do. So it's really hard to see the difference in there. So it's there. You can theoretically see it, but if there's a lot going on, it gets very cluttered. So I think, they need a UX engineer look over that and then iterate on it. But I think that we now have the functionality on the technical side. That's cool already. So kudos on that. And we hope that this will improve over time as well. Okay, Michael, here's the really one last thing, the thing I picked on the AWS announcements. So the AWS Identity Center now offers a streamlined AWS access portal and shortcut links. So I don't know if you've noticed when you log into AWS using the IAM Identity Center, which we do, first of all, the UI changed a little bit. So, that's, I don't know, doesn't matter too much. But what they did is they now have a button in there that says Create Shortcut. And what you can do with that is you choose the AWS account, the IAM role, and you can even choose the destination URL, which could be a specific AWS service in a specific region. So this is optional. And then you click Generate an URL and you get an URL back. And if you open that URL in your web browser, it will, of course, go through the authentication and then redirect you to exactly that AWS account, the IAM role, and even if you want to, the destination URL. So this is handy. I've already started to use that. So I have bookmarks in my browser now pointing me to different accounts that I'm using regularly, and it saves me a few clicks. So that's cool. Little but very handy feature.
Yeah, I mean, I have no bookmarks, but that might be
not a single bookmark. Okay.
No bookmarks.
Okay.
I have a couple of tabs that are always open, but no bookmarks. Yeah.
Okay, you could do that as well, maybe. Okay. Okay, Michael. I think that's it. We'll be back soon. Subscribe to the cloudonaut newsletter, podcast, or the YouTube channel to make sure you're not missing the upcoming shows. And as always, we're looking for your feedback. hello@cloudonaut.io. or find us on LinkedIn or Mastodon. Thanks a lot for joining us today. Bye.
Bye.